So in order to check the total amount of current, we need to equate for T. So the second limit, I'll just drop it here itself because I know that is considered to be 0 itself. Certain amount of heat which is released, which means to say that it is dissipated. Hello everyone, I'm Brinda, Faculty of Physics from Vidhyaashram PRE-UNVERSITY, Mysuru, welcoming you all to session 2 of chapter 7, that is alternating current. So in this today's class, we are going to study about root mean square values as well as how exactly the resistance work out. What is the phase diagram, which is called as a phasor diagram, okay? So all these things will be, which is called the phasor diagram as well as waveform diagram we'll be studying over here. So now let us come to this, that is root mean square value. How exactly we decide this root mean square value? First of all, remember this root mean square value has got something to do with resistance. That is, either you connect the resistance to the AC voltage, that is AC source, or else you connect the resistance with respect to the DC voltage, that is a steady current is getting passed through it. So both the resistors, one is connected to AC source, another one is connected to DC source, which means to say that there is certain amount of heat is released. Okay, so here we deal with the heat released by the resistors, that is when it is connected to the steady current or else whenever it is connected to the AC source. Okay, so heat is released and that heat released at this place will be equal to the heat released at this place is what we study over here. Okay, so here we have root mean square value, which means to say that the two sources produce current in a circuit through the resistor which gives the same amount of heat from the resistor is what the root mean square value tells. So how exactly you go with it? That is how exactly you derive this. So for that we need to consider, we know that, let us consider the amount of heat, let dQ be the amount of heat released when a current I is passing through it, through the resistor R of certain resistance called as R at small interval of time, that is dt. And we know that the current, that is instantaneous value of the AC source is I is equal to I naught sine omega t is what we know. So in order to check the total amount of current, we need to equate for T because it is from 0 to T. That means to say that we are taking complete cycle, the full cycle we are taking and not the half cycle over here. So now the total amount of current, the total amount of heat released can be given as Q is equal to integral of 0 to T. Since dQ is, we know that since dQ can be equated as current I which is passing through the resistance R at certain time interval, since we are calculating the root mean square value, so this current is being squared. Okay, so the same expression we are supposed to put here, that is I square into R into dt is the value what we plot here. So now in order to take Q is equal to I square, we know that 0 to T, I square is I naught sine omega t, so it becomes I naught square sine square omega t into R divided by dt. Here the resistance, that is resistance as well as the peak value which is said to be I naught, or it is the value of amplitude is said to be the constant term which is taken out. I naught square and R comes out and you have 0 to T sine square omega t into dt. And we also know that sine square omega t is nothing but 1 minus cos 2 omega divided by 2 is the equation what we have. This is one set of formulas. So Q is equal to I naught square into R integral of 0 to T. You just take 1 divided by 2 as 1. You just split the integral part. So it becomes 1 by 2 into dt, and we take it as minus here, and again integral of 0 to t, here we take cos 2 omega divided by 2 into dt is what we consider. So now on considering this, we need to equate for this like q is equal to I naught square into r. So integral of half is half into, with respect to t I'll get, so it is 0 to capital letter T, and you have minus, you take half the other side. So integrating cos 2 omega, you get positive of sin 2 omega divided by, you have sin 2 omega into t, wherein this is actually t, I have just left the t out over here. So it is sin 2 omega t, and you have, with respect to this, you will have 2 omega. Okay, so now when you just calculate this, this is from 0 to t back again. So you have q is equal to I naught square r into 1 by 2. Apply this t over here. In order to equate for this alternating current, the complete chapter is about the integrating part, okay? Physics with integration, some of the physical terms as well as mathematical terms, and what exactly mathematical has got, that is the integration part. So you need to know all the trigonometric function, that is all the trigonometric formulas, as well as how exactly to go on with integrating parts, okay? So by applying the limits. So here you have half into 0 goes out. So instead of writing that, I just consider only half into t, and you have minus half into, you have sine 2. Omega is nothing but, yesterday we had written 2 pi by t, and into t into, and this t can be replaced by that t, and if you just consider 0 to the whole term, it becomes 0. So the second limit, I'll just drop it here itself, because I know that is considered to be 0 itself. So now on application of this, you have divided by 2 omega, t cancels with t. So now we know that sine of 2 pi is nothing but 0. So sine of 0 is completely 0. So this term turns out to be 0 with respect to half. So you have q is equal to I naught square r divided by 2 into t is the value. So this is one set of equation. Consider equation 1. So this is the one what we had considered for the I square, that is instantaneous value. So now let me consider the IRMS value of this. So what happens if we consider IRMS value? So I get Q is equal to I square RMS, IRMS value into the resistance and time interval t, same as this set of equation what I have considered over here. So this is said to be equation 2. Equate 1 and 2, you get I square RMS into R into T is equal to I naught square into R T divided by 2. R cancels, T cancels. So what remains is IRMS is equal to I naught, because when the root comes over here, root as well as square cancel. So what remains is only I naught divided by root 2. So this is the IRMS value, or it is called as root mean square of value of the current I. Okay. So you can even write it as IRMS is equal to 0.707 into I naught. So this is the value of root mean square. Okay, so exactly how do you define this? The root mean square value of AC is defined as the square root of mean of square of the instantaneous value. Okay, that is how exactly this is defined. So by this derivation, we'll get to know what is exactly the root mean square value. So you can say that root mean square value of an AC is equal to I naught divided by root 2. So next we are having alternating voltage applied to a resistor. So we here also consider the alternating voltage. So what happens when an alternating voltage is applied to a resistor, where we study regarding the waveform diagram as well as the phasor diagram of this. So first of all, alternating voltage applied to a resistor means to say that there is a AC source which is connected to a circuit which has got the presence of a resistor R. Okay, so the alternating voltage is placed, that is either this way it turns out, or alternating voltage in the sense each and every time its cycle changes. So arrow mark we can't specifically give exactly which side it takes up. Okay, so now alternating voltage which is applied to a resistor, which means to say that we have a voltage value, that is instantaneous voltage, as we had studied in the previous session. V is equal to V naught sine omega t will be the value over here. So, if I is the current through resistor R, if I is the current which is passing through resistance R, then you have V is equal to I into R by the Ohm's law. So what happens? V is equal to I into R remains as it is. So what we can do in the sense, we can just plot I into R is equal to V naught into sine omega t in case of this equation, and you can consider this as equation 2 and this as equation 1. For this equation, I have substituted this equation star. Okay, so now retaining I over there, I just consider V naught divided by R sine omega t. Since we know that V is equal to I into R, I is equal to V divided by R. R is the resistor which is placed over here and which is considered to be constant. So for which the one which varies will be these two. So if I just give the peak values of two, R is remaining stable. So I naught is equal to V naught by R. So I can write this term as I is equal to I naught sine omega t, which means to say that it gives the instantaneous value of current in terms of AC. So now we have the instantaneous value of voltage, instantaneous value of current, where I means the instantaneous values I and V. I naught and V naught are said to be the peak values. Omega t is nothing but the phase what it gives. Omega t phase means to say said as it is a direction what is given over there. So phasor is a vector quantity. Okay. So now here we just give a waveform diagram. In order to check for the waveform diagram, we just plot a axis, y-axis and x-axis. So this is y-axis, which gives either the voltage or current. Here it gives the time what it takes. Okay. So suppose if at time 0, what happens at time 0? What is the value of this V? That is the potential. At time 0, the complete thing, omega into 0 becomes 0. So sine 0 is 0, which means to say that it starts from this point. Similar way, for each and every value of time, how exactly the potential varies is what we have to see. When we just check on to it, we get the sinusoidal wave, that is the sine wave. Okay, similar way, so if this can be, since I have plotted this for the voltage, this is V naught, that means to say that the peak's value, amplitude, and corresponding to that value in case of y-axis you have its instantaneous value, call it as V. Now, when you consider I is equal to I naught sine omega t, which means to say that you have got a current, this is the instantaneous value, as well as I naught is the peak value. So when you just put at time t is 0, your omega, that is the phase, becomes 0, and totally sine 0 becomes 0. With respect to I, it is 0. So always it starts from this position. In order to differentiate it, you just draw in this manner, but it is having a same phase over here. Okay, so it ends and starts both together, only these things. So the phase difference is seen over here. Okay, so that is all. The phase difference usually it is seen here, where this gives omega t, the phase of it in case of x-axis. Okay, so now you can say this is 0, this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi. So the phase of V as well as the phase of I lies together. Okay, this is how exactly the waveform is given. So the phasor diagram of this, phasor diagram, which means to say that it is a vector notation. Okay, phasor means it is a vector. Okay, so phasor diagram of this above form, that is the waveform diagram, is given as, so if this is x-axis and if this is y-axis, it is given in a vector quantity, and the angle what it makes is with respect to omega t. So you have a vector in this manner. So the angle what it gives is omega t, and both lie with respect to each other. So here it is v naught, here you have v. Similar way you have I, which is just below this. So I, and this is said to be I naught. So this is the phasor diagram of this alternating voltage when it is applied to the resistor. Alternating voltage applied to the resistor, which means to say that it has got a phasor diagram which lies, that is two phases, the phase of current as well as vector both lie in the same line. That is why you can say that the phase, in case of phasor diagram, the phase difference between V as well as I is said to be 0. It is nil because here it starts and ends at the same position, because the phase difference usually is seen in x-axis. If suppose it starts from here, you can consider this as a phase difference, but it is starting and ending at the same point where exactly the voltage as well as the current starts as well as ends. So this is all about the alternating voltage when it is applied to the resistor. Next we are going on to power in a purely resistive circuit. So we have to check out the average power of it. Okay, so for that we need to again consider a AC circuit to which the circuit is connected to the resistor of certain resistance and certain interval of time there is a passage of the current. Okay, so now we just check out in a purely resistive circuit. So now we have, whenever there is a current which is flowing through this circuit, you have a resistance R over here. So it passes through the resistance R and the heat energy is released, okay, due to the heating effect of the circuit. Due to the presence of resistance, there is a certain amount of heat which is released, which means to say that it is dissipated. Okay, so in order to check out what is the power exactly which is associated with it, we know that power is equal to work done per unit time. So what is work done? Work done can be given as, that is, the potential is equal to work done by a charge. So W is equal to V into Q can be considered. So we consider it as V into Q divided by delta T. So transferring of the charges or the charges per unit time is said to be current, which is said to be I. So we have P is equal to V into I concept. So this will be the formula for which we start acting with respect to this. That is, we have P is equal to what is V and I. According to this alternating current, we know that voltage V is equal to V naught sine omega t. This is the relationship between the instantaneous terms as well as the peak value terms. Okay, so I is equal to I naught sine omega t. So these two are the two set of questions for which we write P is equal to V naught sine omega t into I naught sine omega t. So on considering two, we have P is equal to V naught into I naught, within brackets it is sine square omega t. So in order to check its average value of power, total average value of power, we need to integrate it for the full half cycle, that is from 0 to t. So we have integrating power with respect to time. So we have P is equal to V naught into I naught into sine square omega t into dt. So we just consider it as P is equal to integration from 0 to t V naught into I naught sine square omega t into dt divided by integration 0 to t with respect to time, which is associated with the power over here. Okay, so now P is equal to, integrating time, you get 1 as T and 1 as 0. So it is 1 by T. So you take it outside. So you know V0 and I0 is said to be a constant term. So I just take V0, I0 also outside the value over here. So we have integration 0 to T sine square omega T into dt value. So P is equal to, this is the average term what we consider. So V0 is equal to I0 divided by T. So equating for this, you will have integration 0 to T. I know that 1 minus cos 2 omega T divided by 2 into dt will be the value for the sine square omega T equation. That is the formula. So having this, I just take up with P average is equal to V0 into I0 divided by, you have T, and integration of 0 to T, we are integrating first with half and then I go with integration 0 to T, just cos 2 omega T, and here I take 1 by 2 outside. Again I take this denominator for this and then I equate this as V0 into I0 divided by T. On equating this, 0 when multiplied with half will be 0. So I just integrate this term and put the above limit, that is T. So it becomes T divided by 2. And I have minus, again half goes, so cos omega T becomes sine 2 omega T divided by chain rule. Again I have 2 omega 0 to T. Again equating the sign with 0 becomes 0. So I just leave that and equate with respect to T. So P average is equal to V0 I0 divided by T, and you have T by 2 minus half, which means to say that 4 omega, and sine 2 into omega. Omega is 2 pi by T. T cancels, omega 2 pi. So sine 2 pi is 0. Complete term turns out to be 0. 0 minus 0. So it goes with 0. So P average is equal to T cancels. I have V0 into I0 divided by 2. V0 into I0 divided by 2. So I'll just half this 2, that is root 2 into root 2 is 2. So I'll just give half part of the 2 to V0 and other half to the I0. So P average is equal to V0 divided by root 2 into I0 divided by root 2 is the concept. That is P average is V0 by root 2, I0 by root 2. So we know that V0 by root 2 is P average is equal to I0 by root 2 is nothing but IRMS value. Similarly, V0 by root 2 will be VRMS value. So P average is the product of root mean square value of the voltage as well as root mean square value of the current. This is the value for this power in a purely resistive circuit, what we have to understand. And then further we can equate this as, we know that V is equal to I into R. So what happens in the sense, we have P is equal to V into I. So it becomes I into R into I. So I get I square into R. So I can rewrite this as, that is, for that if I apply, I have P vector is equal to I square RMS into R. So instead of P, I'll just apply this VRMS into IRMS is equal to I square RMS into R. Square square cancel. So what remains is VRMS is equal to IRMS into R. This is with respect to V is equal to I into R, Ohm's law. Okay, so this is how exactly we derive for power in a purely resistive circuit, which you have to know. So in our today's class, we have derived the equation for root mean square, alternating voltage when applied in the circuit, and lastly, we have dealt with power in a purely resistive circuit. Let us all meet in our next class with the upcoming session of the same chapter. Until then, have a good day. Thank you.